Ever wonder how AI systems stay sharp in a world full of tricky data? Today, we're diving into a game-changing framework called DINA that's redefining resilience in natural language processing. Let's break down the challenges it solves, how it works, and why it matters for the future of AI. The problem: two threats to AI reliability. Imagine an AI tasked with filtering spam messages. Now picture two scenarios. 1. External attacks. A spammer alters a message just enough to bypass detection, like swapping "add me on WeChat" with "power mouth me on WeChat." To humans, it's obvious, but to an AI, the subtle change can erase its ability to flag the content. 2. Internal label corruption. What if the humans labeling training data, like content moderators, get overwhelmed and mislabel messages? This noisy labels problem is like giving an AI a faulty blueprint, leading it to misclassify everything from harmless chats to malicious content. These aren't theoretical issues. They're real-world challenges that degrade AI accuracy, and until now, they've been tackled separately. But what if we could defend against both at once? Enter DINA, the dual defense framework. DINA isn't just another AI tool. It's a strategic shield combining two cutting-edge techniques. Noisy label learning teaches models to identify and correct incorrect training data. Adversarial training prepares models to resist deliberate input tampering. Think of it as training your AI to be both a detective, spotting fake labels, and a bodyguard blocking tricky inputs. Let's unpack how it works. How DINA tackles the challenges. DINA's strength lies in its four-stage process. 1. Weak learners. It starts by training basic models on fragmented data, creating a diverse team of experts that avoid overfitting to noisy inputs. 2. Synthetic noisy labels. Researchers simulate real-world label errors by using crowdsourced feedback, teaching the AI to distinguish between genuine content and corrupted signals. 3. DivideMix refinement. This step acts as a quality control check. The model compares predictions across different data subsets, iteratively filtering out noise and improving accuracy. 4. Adversarial training. Finally, the AI is tested against crafted attacks, like altered spam messages or misleading queries, to build resilience against real-world threats. The results: a resilient AI in action. In real-world tests using data from an online gaming platform, DINA outperformed existing models by a significant margin. When faced with adversarial attacks, it maintained 90.3% accuracy, compared to 79.8% for baseline systems. Even when label corruption was introduced, DINA stayed remarkably stable, proving its dual defense approach works. Why this matters? DINA isn't just a technical fix, it's a blueprint for building AI that thrives in chaos. By addressing both internal and external threats, it paves the way for safer content moderation, more reliable customer service bots, and systems that earn human trust. The bigger picture. This research highlights a critical shift in AI development, moving from isolated solutions to holistic defense strategies. As AI takes on more high-stakes roles, frameworks like DINA ensure they're not just smart, but resilient. The team behind DINA is already exploring how to expand this approach to other tasks, from medical diagnostics to autonomous systems. So next time you interact with an AI, remember, behind the scenes, innovations like DINA are working tirelessly to keep things fair, accurate, and secure. Thanks for watching, stay curious, and let's keep pushing the boundaries of what AI can achieve. Have you ever wondered how AI systems stay safe from tricky attacks? Imagine a world where bad actors try to trick AI into missing harmful content, like swapping words to hide spam or spreading misinformation. This is what researchers call adversarial attacks, and they're a big deal in AI safety. Today, we're diving into a groundbreaking solution called DINA, a framework that's like a superhero for AI, protecting it from both sneaky internal tricks and external threats. So how do these attacks work? Think of it like this. If someone alters a message just enough to fool an AI, like replacing spam with spam or swapping synonyms, those tiny changes can make the AI miss the real problem. To fight back, researchers use adversarial training. This means teaching the AI to recognize these tricky patterns by feeding it examples of attacks during training. It's like training a guard dog to spot intruders by letting it practice with decoys. But there's another challenge: noisy labels. These are incorrect or inconsistent labels in training data. Think of them as faulty blueprints for building a house. If the AI learns from bad data, it can make mistakes. That's where DINA comes in. It's a four-stage system that tackles both internal noise and external attacks. Let's break it down. First, DINA trains weak learners, basic models that don't get overwhelmed by messy data. These models work on different parts of the data, creating a diverse team. Then they synthesize noisy labels, like using crowdsourced feedback to mimic real-world label errors. This helps the AI practice spotting fake signals. Next, DINA refines the main model using a technique called DivideMix. It's like a quality control check. The model learns to separate real content from noise by comparing predictions and improving itself iteratively. Finally, it adds adversarial training with crafted examples. Think of it as simulating real-world attacks to make the AI tougher. The results: DINA outperforms traditional models by a lot. In tests, it maintained 90.3% accuracy even when faced with tricky attacks, while the baseline model dropped to 79.8%. And when researchers messed with labels, DINA stayed resilient, proving it's a powerhouse for real-world AI safety. So what's the takeaway? DINA isn't just a technical fix. It's a blueprint for building AI that's robust in a world full of tricks. Whether it's filtering spam, catching misinformation, or protecting customer service bots, this framework shows how combining smart training strategies can make AI safer, smarter, and more reliable. Thanks for watching. If you want to explore more about AI safety or how systems like DINA work, hit subscribe. Stay curious and remember, every great technology needs a shield to thrive.